Welcome back, fellow explorers, to Project Opono. In the last episode, we saw how the creatures of Opono made the monumental leap from life in the water to life on dry land. In this episode, we will see how these 8 pioneering clades diversify to fill all of the land's vacant niches. We will begin our journey by detailing the descendants of the kitria. As the kitria begin carpeting the continents, intraspecific competition may begin to rise. If this competition were to get too great, the kitria may begin to adapt. Perhaps some kitria begin to grow larger and taller to effectively compete with their moss-like relatives. This may give them a body plan similar to the extinct prototaxites of ancient Earth. Due to their newfound size, they may need to evolve a stronger core to keep themselves supported, or they would fall over. We will call these towering moss pillars the tawamosu. They can grow up to 26 feet tall. Soon after the tawamosu evolve, the competition for light will again increase. As a result, some tawamosu may evolve to be smaller, to not compete with their larger relatives. This will also mean that these plants will have to adapt to lower light levels. Because of this constraint, they may begin to feed on dead plants, while still retaining their photosynthetic pigment. If they are not growing on a dead body, we will call these small semi-saprotrophic tawamosu the parvutawa, and they grow up to 10 inches tall. As the dead bodies of the tawamosu continue to pile up, the parvutawa may not be able to keep up with the mass of decaying matter. As a result, a more specialized clade of saprotrophic parvutawa may begin to evolve. These plants may fully lose their pigment as they transition to a fully saprotrophic lifestyle. As this happens, their size may shrink even further. The final adaptations these decomposers may evolve is a thin bubble on their tops. This bubble will be made of a thin layer of their organic tissues. Once these parvutawa are ready to spread to new areas, they will inflate their bubbles with spores until it is about to burst, and it is at this point that the bubble does burst, releasing their spores into the air in the hopes that they will land on a new dead body to grow and mature. However, the cores of the tawamosu may be too difficult for just their roots to decompose, so they may evolve to produce a mild acid that can break down the tough, woody core of the tawamosu. We will call these bubbling decomposers the barunvara, and they can grow up to 3 inches tall. And now that we have detailed the global evolution of the kitria, we will keep exploring the endemic clades of the 2 continents. However, we must turn our focus to the coasts for now, as we see the evolution of one of the strangest clades yet seen on Opono. The oceans of Opono have had a massive decline in oxygen levels. Survivors of this decrease in oxygen may need to adapt to lower oxygen conditions. One way around this is to evolve to breathe air. This is due to the fact that air has much more oxygen than the oceans. Perhaps a branch of open ocean Panicato evolves to live in the coastal swamps of the 2 continents of Matsi and Apovlitos. The issues these animals will immediately face are the lack of buoyancy in air, and not being able to support their weight outside of water. However, most Panicato at this point have evolved some form of internal support. Perhaps one radiation of these Panicato evolve a simple cartilage skeleton to support themselves in the water. This will allow the terrestrial forms to support themselves on land, while still retaining flexibility. Along with this, their body plan may change drastically due to the change in habitat. They may evolve to slither along the muddy coasts, using their side fins to drag themselves along it. However, a more efficient method of moving on land is by hopping from place to place. So perhaps these terrestrial Panicato evolved to use a combination of their side fins and tail fin to leap quickly, to evade predators, or to leap on small prey. This may give them a similar body plan to the mudskippers of Earth. As a result of these changes, we will call them the hopaika. They grow up to 15 inches long and can live for up to 5 years. They can leap up to 3 times their body length when they need to. The hopaika will be a common sight in the swamps of Matsi and Apovlitos, as well as on the many islands dotted in the vast ocean. Now that we have detailed these new land dwellers, we will now continue to diversify the ecosystems on the 2 continents. We will continue our journey on the lonely continent of Apovlitos. Soon after the tawamosu Parvutawa, and Barunvara evolve on Apovlitos. The Parvacormo will make landfall. However, due to competition with the Tawamosu, the Parvacormo may need to find other areas to grow, because of the Tawamosu taking up all the area of the coasts. This may result in the Parvacormo and Tawamosu exhibiting a strange form of niche partitioning. While the Tawamosu evolved along the coasts of Apovlitos, the Parvacormo evolved around the inland rivers and lakes. This means that the Tawamosu and the Parvacormo may be able to coexist with one another, forming two distinct types of forests. Along the coasts, the Tawamosu may form vast swamps in areas with sufficient and constant rainfall due to their lack of tough outer casing. Further inland, the Parvacormo's tough woody bark may allow them to retain water within the main plant body, allowing them to form vast inland forests and savannas in drier regions. Wherever these two types of forests meet, a vast tropical rainforest consisting of towering woody trees and moss spires may be formed, where the two plants will coexist in relative harmony. However, as is with the Tawamosu, the Parvacormo may eventually begin to exhibit intraspecific competition between species, thus resulting in some Parvacormo growing taller than their ancestors. However, due to their woody trunks, these larger Parvacormo may be able to grow much taller than any Tawamosu could, eventually replacing them in the mixed rainforests as the dominant large plant, relating the Tawamosu to mid-sized vegetation. These new trees may evolve larger leaves, along with whole new leaves on their branches, to maximize their photosynthetic surface area to collect more sunlight. Along with this, they may evolve to support their leaves using water pressure, keeping them pointed upwards towards the sun. We will call these new trees the Diversification, and they can grow up to 22 meters tall. Soon after all of these new plants evolve on Apovlitos, the Cyspatas will make landfall. The earliest Cyspatas were small generalist herbivores, and so one branch may stay small, becoming what could be called bugs. We will call this group of small Cyspatas the microspheres. Their diversity may be too great to detail every single species, but we can still map out the major groups among them. Some may evolve their tentacles into long tendrils lined with sharp, needle-like teeth to slice through the leaf litter carpeting the ground. Others may evolve muscular lower tentacles to chew through the bark of the Diversification and other woody plants, while still others may evolve spikes on their lower tentacles to stab into the plant and drink up their vascular fluids by letting it flow down through grooves in the tentacles. As all of these herbivorous microspheres evolve, others may begin to feed on them. Some may evolve longer legs and tentacles to chase after prey and bring them close to their mouth. Others may evolve massive, sharp teeth to crush and rip apart prey they ambush, while another group may evolve to feed on dead and decaying matter, assisting the Barunvara in breaking down dead bodies of plants and animals. As the microspheres begin to colonize Apovlitos, other Cyspatas may take the opposite approach, gigantism. However, the hydrostatic skeleton of the Cyspatas may put a limit on their maximum size, as it isn't good at supporting large amounts of weight. But while the lower gravity of Opono may alleviate some of their weight, they may still need to find a new way to support their large bodies. This may come in the form of a skeleton made up of many rings of cartilage. These rings may be mainly in the legs and torso of the creature to support their bodies and protect their internal organs. We will call this group of Cyspatas the megalapids. Soon after the megalapids evolve, one branch may quickly specialize into the niche of megafaunal herbivores. They may evolve a larger body and digestive tract to be able to ingest and break down the large amounts of plant matter they consume. Their tentacles may lengthen and strengthen to be able to pull whole branches off of the trees they are feeding on, and in their stomachs may be many spikes of cartilage to help rip apart the plant matter and help them digest it. However, an increase in body size also comes with some new reproductive behaviors. While the microspheres have evolved are selection to lay thousands of eggs in a single clutch, these large megalapids may not be able to raise that many young. As a result, the megalapids may evolve K-selection, having few amounts of offspring, but investing more heavily into those offspring in the hopes they survive into adulthood. We will call this group of megalapids the contrapod. They grow up to 5 meters tall and live for up to 37 years. Another group of megalapids may go for the opposite niche, megafaunal carnivores. These animals may evolve long slender bodies to snake through the dense vegetation they hunt in, along with the yellow skin coloration to blend in with the vegetation around them to stay hidden from their prey. Their tentacles may evolve to be lined with many barbed teeth to hook into the flesh of their prey and rip out large chunks of flesh and cause fatal bleeding. This may mean that these megalapids may not specialize for speed, instead specializing for an ambush hunting lifestyle. We will call these large ambush hunters the leptosoma. They grow up to 3 meters long and live for up to 25 years. The sarcopods will hold dominion over the Apovlitoan ecosystems for thousands of years before the Panoplopods make landfall. However, once the Panoplopods do invade the land, the Apovlitoan ecosystems will be thrown into chaos. Soon after the Panoplopods evolved, they may split into 2 separate lineages. One may retain the exoskeleton of their ancestors, adapting for the niches of adaptable generalists and insectivores. The other may evolve to internalize their exoskeleton into an endoskeleton, specializing into the niche of large herbivores and predators. We will call the lineage of exoskeleton-bearing Panoplopods the coriscacle, and the lineage of endoskeleton-bearing Panoplopods will be called the cocolophoros. Soon after the coriscacle and cocolophoros diverge from one another, they may immediately begin adapting for different niches within the ecosystem. One branch of cocolophoros may evolve into the niche of large herbivores, specializing to feed on the Diversification and other cormophytes. To do so, however, they may make some radical changes to their body plan. Their legs may evolve to become larger and more muscular to support their newfound size. Their trunks may evolve to elongate massively to be able to reach the very tops of the trees, with teeth lining the inside to rip apart the plant matter. They may also evolve a tail on their backs to stabilize their bodies so they don't tip over while feeding, and their eyes may evolve to be positioned on stalks to be able to see over their body and at their food. We will call these massive cocolophoros the macroproso. They grow up 8 meters tall and live for up to 41 years. Another group of cocolophoros may evolve into the niche of pursuit hunters. In convergence with the macroproso, they may evolve more muscular legs to support their body, a tail to help with stability, and eye stalks to see above their trunks and find their food. However, the trunks of these creatures may undergo massive specialization. They may evolve a series of bones and tendons in the trunk to be able to open and close it at will, and to be able to bite down on prey very hard. They may also evolve a beak at the end to cause extra damage to their prey, with the beak evolving jagged edges and a sharp point to stab into their prey. Along with this, they may also evolve to be able to extend and contract their trunks, to be able to attack prey from a distance or at a close-up range. We will call these speedy predatory cocolophoros the Grigorovavgo. They grow up to 4.5 meters tall and live for up to 31 years. Soon after the macroproso and Grigorovavgo evolve, they may enter competition with the megalapids. In nature, no two clades can fill the same role in their ecosystems without competing with one another for resources and food. However, instead of extinction being the only possibility, the megalapids and the megafaunal cocolophoros may evolve niche partitioning, specializing for different food sources or environments. In the case of the herbivorous contrapod and macroproso, the two clades may specialize to feed on different types of plants. The macroproso, being as large as they are, may evolve to feed on the largest of plants, such as the Tawamosu, Diversification, and other large cormophytes. Meanwhile, the contrapods may evolve to feed on smaller, shorter vegetation such as the Parvutawa, Barunvara, and any other small plants. Meanwhile, the predatory Leptosoma and Grigorovavgo may specialize for different methods of hunting prey. The Leptosoma, not being as flexible and fast as the Grigorovavgo, may evolve to ambush large prey like the contrapods and macroproso, while the Grigorovavgo may evolve to prey on smaller, faster prey, such as the ancestral Coccolophoros and the Coriscocle. The Coriscocle, on the other hand, may quickly begin to fill the role of generalists, evolving into any niche the sarcopods and the Coccolophoros haven't filled. One branch of Coriscocle may specialize for the niche of an insectivore, hunting small prey like the microspores. This may result in them evolving several new ways of making their hunting as effective as possible. Their trunks may shorten dramatically to avoid them being damaged while chasing small prey. However, the two tendrils at the end of their trunk may elongate dramatically to be able to grab any small prey from a distance or from within small gaps or burrows. To defend against predators, the exoskeleton on their main body may fully fuse into a single plate, with a horn at the front to defend against predators. Meanwhile, their legs may be positioned completely under the body to make their running as effective as possible, with the exoskeleton there being the only part with segments to allow them to bend their legs. We will call these specialized Coriscocle the Nososviri. They grow up to 1 foot tall and live for up to 5 years. Another branch of Coriscocle may specialize for an arboreal lifestyle, evolving to mimic the leaf of a Gavarizaphyta. Their exoskeleton may evolve to be taller with many more segments, making them as flexible as possible, while still maintaining the image of a leaf on the plant they are on. Meanwhile, the exoskeleton on their legs may shrink, with the only remaining part being on the knees of the creature to keep their legs supported. Their feet may also split into 2 toes to allow them to stay as stable as possible on the branches they walk on. These Coriscocle may evolve to eat any tree-dwelling microspores that may find inside the tree they are on, or even the leaves of the tree itself. We will name these arboreal Coriscocle the Bullatiru. They grow up to 15 inches tall and live for up to 4 years. In response to the threat that is the Bullatiru, some tree-dwelling microspores may evolve a way of escaping their presence. This may start off as some microspores beginning to hop between branches to escape the Bullatiru trying to feed on them. However, this may lead to the risk of falling from the tree and dying from the Nososviri on the ground below. So these microspores may evolve a patagium stretched between their limbs to allow them to glide safely from branch to branch, acting as a parachute. However, as this behavior evolves, some of these microspores may take it to its obvious culmination, powered flight. As these microspores patagium begin to specialize further and further, they may eventually evolve a way of controlling where they will land. They may start off by flapping their arms up and down to keep themselves airborne for longer, using their front and back limbs to turn their bodies in the air. And eventually, this behavior may culminate in the evolution of the first ever flying animals on the planet. The wings of the flying microspores may be supported by 2 fingers at the ends of their middle pair of legs, as well as the hind legs to expand their wing size. However, if they want to truly take over the skies, they must evolve a form of internal support, as their hydrostatic skeleton may not be enough to keep their bodies and wings supported. So in convergence with the megalapids, the flying microspores may evolve a skeleton of cartilage. However, instead of their skeleton being made out of rings of cartilage, these creatures' skeletons may evolve the more traditional, with long struts extending into the limbs supporting the wings, as well as the wing itself. With all of these adaptations, these flying microspores will be in a position to evolve into thousands of different species and dominate the skies of Opono for millions of years before any vertebrates take to the skies. We will call these flying microspores the Bogwingu. They range in size from a few centimeters to over a foot in length, and live anywhere from a few weeks to over a decade. These creatures may be some of the first contact between Apovlitos and the rest of the world, being one of the first animals to spread from continent to continent. As the Bullatiru and Bogwingu begin to dominate the trees, a clade related to the Leptosoma may evolve to feed on them. they may evolve to be smaller than their ancestors, to still be supported on the branches they cling to, along with evolving claws on their feet to hook onto said branches. They also may have a flatter body shape, to be more effective at clambering through the trees. Along with this, their tentacles may evolve to be longer, to ensnare prey that gets too close to them, still having the ambush hunting lifestyle of their ancestors. We will call these arboreal predators the Pseudocopodia. They grow up to 2.5 feet long and live for up to 15 years. It is clear that the isolated continent of Apovlitos plays host to a strange terrestrial ecosystem. From the strange macroproso to the aerial bogwingu, the land ecosystems of Apovlitos have been fully explored and have the potential to produce some very strange forms going forward. In the next part of this episode, we will head over to Matsi to continue to expand the terrestrial ecosystems of Opono. Special thanks to the fan artists on Discord who submitted fan art for part 1 of this episode. You all make this series much better than it would have been without your help. Thank you all so much for watching. Don't forget to subscribe, like, and leave your suggestions on what strange forms of life the continent of Matsi will produce. See you in the next part of this episode.